Hello and welcome to the Bearded Mathman's YouTube channel. Hey, in this video, part 2 of imaginary numbers, what we're going to be talking about is how to do arithmetic with imaginary numbers, complex numbers, and all the like. So in the first video, we introduced you to what imaginary numbers were, or what they are. In this video, we're going to talk about how arithmetic works. We already did the refresher, so we should be good to go. If you haven't watched the first video, you don't really need to, if you understand what imaginary numbers are. But if imaginary numbers are new to you, it would probably be beneficial to really understand what they are, where they come from, how complex numbers work. And to do that, you should watch the first video. I'll put a link in the description below so you can access it. All right, so let's get to basic arithmetic here, right? Let's talk about addition and subtraction, and then we'll talk about multiplication and division, right? So with addition and subtraction, let's say you had 3x plus 7x. Well, those are like terms. You can add them to get 10x, right? Whereas if you had 3x plus 7, those are definitely not like terms. So you can't add those together because 3x and 7 are different. If you were to try to add these together, you would actually have violated the order of operations. You see, this addition of these two things, these are repeated multiplication. These are the same exact thing. So if I put a number there like 5, we can see very easily that we could switch the order. We can add these together first, or we could calculate these products. 15 plus 35, that's 50. So you can add them first, or you could just multiply them first, right? But moral of the story is, if they're like terms, you can add them. If they're not like terms, you cannot, right? Well, that same exact process for the same exact reason holds true for imaginary numbers. 3i plus 7i is 10i. Do you see? But 3i plus 7, well, that's a complex number. You cannot add those together. They're not like terms. They are different units entirely. Now, this is a complex number, and usually we're going to be writing the real part first. The imaginary portion of that complex number goes second, right? So the moral of the story, adding and subtracting. Think about like terms. If they're like terms, you can add them or subtract them. If they're not, you can't. So a real number and an imaginary number, you cannot combine with addition or subtraction. You can combine imaginary numbers together with addition and subtraction. You can combine real numbers together with addition and subtraction, but you cannot combine real and imaginary numbers together with addition and subtraction, right? So you're just going to follow the order of operations. You're going to be done easy, right? Now, multiplication and division, that's where things get a little bit trickier, okay? So 3x times 7x, it doesn't matter if they're like terms or not. You can still multiply. You can just treat these like coefficients. 3x times 7x, well, that's 21x squared, because x times x is x squared. 3 times 7 is, of course, 21. Whereas here, not like terms at all, but it doesn't matter because you're multiplying, right? Doesn't matter at all. So same with division, doesn't matter, but you can reduce. If you have like terms, right, that means you have a common factor. That means you can reduce, right? So this would be 3/7. Now, let's see how that works for imaginary numbers. If you had 3i times 7i, well, 3 times 7 is 21, right? I times I is I squared, but we can simplify I squared because we know that I times I is equal to negative 1, so 3i times 7i is negative 21. You see how that works? I times I is I squared, so you got to be really, really careful with that. All right? Now, so let's see how an application like this would work. Let's say we had 3 minus 2i, and we wanted to square that. Well, squared means the base times itself, and the base in this case is everything in the parentheses. So this is 3 minus 2i times 3 minus 2i, right? And we could use FOIL, the shortcut, but I think in this case, it would be a good idea to write it out because I want to really be clear about what happens with the imaginary part of these complex numbers. So we're going to distribute. 3 times 3 is 9. 3 times 2i, 6i. And positive times a negative is still negative. Here, negative 2i times 3 is negative 6i. And negative 2i times negative 2i is positive 4i squared. Do you see? So 9, right? Negative 6i, positive 4i squared. We can combine these two. Those are like terms, right? So this is going to be negative 12i, but here's the issue. Do you see this right here? This is going to be negative 4. So what we're really going to end up having is we're going to have 9 minus 12i minus 4, and that's 5. 9 minus 4 is 5, so it's 5 minus 12i. Do you see? So it's just like before. The only thing different, it's just like multiplying before, the only thing different is that I times I is I squared. You have to be careful with the exponents and those imaginary numbers, okay? Other than that, it's just like multiplying this together if it's as though it said 3 minus 2y squared. All right. Now, let's talk about simplifying something like this again. The square root of negative 24. Well, 24 is 4 times 6. 4 is the biggest perfect square that's a factor of 24. But the negative part, well, we need to take care of that too. That's negative 1. Do you see? So what we're going to end up having is 2i times the square root of 6. So it's going to be a plus or a minus, right? We could have plus 2i times the square root of 6 or minus 2i times the square root of 6. Typically, we put the I, that imaginary component, at the end of the number. We have to be careful here because we don't want it to look like the square root of I. Yeah, there we go. So, to summarize, when you're adding and subtracting, it's the same with complex numbers as it would be for adding or subtracting like and unlike terms. So if they're both imaginary, you can add or subtract. If they're both real, you can add and subtract, but you cannot add and subtract a real number with an imaginary number. However, you can multiply them. No problems there whatsoever. The only thing you got to be careful of is when you have I times I, that's I squared, that becomes negative 1. So this might be tricky and new. I would suggest that if you would like some more information and practice on this topic, you can visit my website, thebeardedmathman.com. I will put a link in the description down below. You can find some good, great, fantastic, wonderful practice problems, other topics, all kinds of fancy things. Hey, I hope this has been helpful. If it has, give it a thumbs up. Share it on social media. Leave me a comment down below. I'd love to hear from you. Hey, have a great day.